Okay, hi everybody. Welcome to week 5. We haven't been in this room for a while. It seems like ages ago that we were last here. It was only 2 weeks ago though, right? All right. So as always, the link to the code is available. Last week we did 2D arrays, and actually, the 2D arrays was in a pre-recorded lecture, so hopefully people have watched that. It's very important to know about 2D arrays to do the assignment. Hands up who's started the assignment. Okay, we've got quite a few hands, which is good. That's excellent. How's everyone going with it? Good, bad, otherwise, okay? Yeah. So if you haven't started, definitely start as soon as you can. And I think I've said this before, if you're having trouble getting started because you're overwhelmed and you don't know where to start, talk to your tutor, go to a help session. Don't leave it to the last minute and just get more and more sort of stressed about it. Okay. We also looked at strings last week. We'll do a little bit of a recap of strings today. We didn't get up to arrays of strings or command line arguments, so we'll do those today. Then in the second half, we will do a revision program. It'll be a bit of a longer programming example than we usually do in lectures. And we're going to be putting basically everything together into one program, basically up to 2D arrays. And hopefully that will help you get started with the assignment if you haven't started already. All right, are we ready to go? Now, how's everyone feeling about strings? Who loves them? No one. All right, so strings are just a collection of characters. All right, that's what we're trying to do when we use strings. Store a collection of characters. This allows us to store text and, people's full names instead of just their initials or whatever. And it allows us to store them in variables as well. Now, in C, there is no keyword string that you say, my variable is of type string, like you do with int. We just use an array of chars. But there's something very special about our array of chars. If it's a string, that is this null terminator. And does everyone remember what this null terminator does? Or why we want it or have it? Yeah?
Make sure that the string ends.
Yeah, that's right. It shows where the string ends. And that means by having this in there, we don't need to keep track of the sizes of every single string in our program, because we tend to have lots of different pieces of text in our program. We don't have to have separate integer sizes for all of them. This thing tells us where the string ends. Okay, but other than that, it's kind of just an array. There is special syntax built into C though to help us with strings. So for example, the double quotes, which you've been using all term with your printf statements, the double quotes mean strings. And if we assign this hello string, well, if we initialize this and to hello like this, gosh, I can't speak, this is creating a string. So we've got our variable name called word, we've got the square brackets, which is saying this is an array, it's an array of char, and that's what we use for a string. Now, this notation allows us just to type it in easily in double quotes, but C will go and put each character into the array, and it knows to put this null terminator at the end. It'll do that for us. And in this case, we haven't given it a size. It'll make the array the exact size to fit that exact string. And sometimes that's all you want, and that's how you do it. Now, to print it out, the easy way is just to use %s. We do printf %s, and it can print out our string. Whereas usually for an array of other types that's not a string, we'd have to go and maybe do a loop. Now, on this other side, I do want to show you how you loop around in a string, because sometimes you need to do that. You don't need to do it to print the string. You can use %s, but sometimes you want to do things character by character. Like you might want to go through the string and see how many vowels are in it, or see, I don't know, convert everything to capital. So this is just an example of how you would do a loop through a string, character by character, because it's a tiny bit different. We're still starting at index 0 and going one index at a time. Every index in our string, at every index we've got a char, so we can print it with %c. But we don't have the size, so we're not going to have our loop stopping, or like our loop going while I is less than some size. We have to keep checking, is this character that I'm looking at, the word at index I, is that equal to this null terminator? And we check that each time. Eventually, if we've got a proper string, we'll get to this null terminator and the loop will end. And this is basically how printf %s works. So if you're mucking around with your string and you don't have one of these, your program's likely to crash. Okay. Is everyone sort of happy with all of that stuff? Yep. A couple of questions? Yeah, I'll go with you first.
I was just wondering, let's say you don't know the size of the string. Is there like a situation where you don't like you cannot know the size and you cannot know like and you can just initialize it, not initialize it, like declare it?
Oh, so you don't know what you want to put in it?
Yeah.
Yeah, so the question is, I guess, what happens when you don't know what string you're going to put in it? Like you might be creating a string variable for somebody to enter their name. You don't know what their name's going to be. You don't know how big to make it. Well, this is unfortunately where we basically take a guess and we might make it of size 100 or some size that we think is okay. And you know, these are limits that sometimes come into play. Has anyone ever, I don't know the length of people's names here, but does anyone have a very long name and they've tried to type it into a piece of software and it's been too long? There are cases of that where there's some limit that's set somewhere and somebody's name's longer than it. So unfortunately, people's best guesses aren't always correct. But that's what we've kind of got to do in this case. And, yep.
If we can print strings, then why cannot we use scanf for strings?
There is a scanf %s, but, and I'll talk about what we do want to use. In scanf %s, it doesn't really force you to make sure you don't overflow the string. So like in that situation we were just talking about, if I made a string of size 10 and somebody entered their name and it was size 20, scanf, just the default way you'd probably use it, will just allow you to overwrite the buffer, overwrite the array. And that's a massive security vulnerability.
So do we use?
We don't want to use scanf, we want to use fgets. Yep. So I'll show you on the next slide. Fgets, built into fgets, is the fact it's going to force you to tell C how big your array is. Now, of course, you could type in the wrong size and get that wrong, but it's built in to encourage you to make sure you don't have these security vulnerabilities, because DCC will stop our program, but other compilers, and in the past, this was a big source of security vulnerabilities for many years. It's still out there and around, but I don't think people were on top of it before. But people can type in certain data on purpose to overwrite other data that's next to it when you're overwriting the array and hack into things. And yeah, so we don't want to use scanf %s, and it's sort of illegal in the style guide, I think. Yep.
Just about scanf, when we're like checking through like each, do we put like sometimes like if we're taking a user input and we're like checking each like character in a loop, would we put like new line or would we put an alternator?
If we were going,
If it's like you're taking in user input.
if we're taking in user input, oh, well, actually, let's assume we're not using scanf for strings. let's just assume we're not.
F gets.
Right, for fgets, yeah. When we use fgets, so first of all, I'll talk about fgets, then how we'll use it in a loop, and I will show you that today as well. With fgets, this is how we want you to read in your strings. This will read in basically one string. This is where you're reading it into. This is telling fgets how big the string is. This weird keyword is saying it's reading it from standard input. So that's what we're always going to type. Standard input by default is just where the user's typing into the terminal. So it's reading in what the user's typing in. In other scenarios, fgets can read from different places. You'll see that in future courses. But for us, it's always std in. Now, imagine we've got a string of length, like the maximum size of the array is 6, and I typed in hi, and then I pressed enter. We're going to end up with this in our array. We'll have the h, I, and new line because I typed all that in. So hopefully we know when we press enter, if we're reading in characters, enter will be a new line. And fgets will make sure it's got this null terminator. And the rest of this is just treated like rubbish. Even if there's data lying around in there, anything after this null terminator is officially not actually in the string. It's lying around in the array, but it's not counted as being part of the string. So fgets will read in until you've typed in enter, or if you type in too many characters, it'll cut you off and it'll do the fgets for however many characters fit in here. So if I typed in hello, new line, I'd get the HELLO. Fgets would cut me off there. It knows it can't fit the new line I typed in if it needs to fit this null terminator. So that one quarter fgets would only read in the hello. Does this make sense? Now, if we did a second quarter fgets, the next quarter fgets would end up basically, what would it end up with if we did a second fgets? It ends up with this new line. Whoops. There would be a new line and then the null terminator, and that would all just be garbage if I did two calls to fgets. The first fgets would get hello. The second fgets would get whatever's left, which is the new line. Okay, so that's fgets, and you'll get used to it. Now, we will see it in a loop. Basically, does everyone know what, you've all done like control D loops, right? Where you might want the user to enter data, and when they don't have any more data to enter, they press control D. And you might have seen that with scanf. We can do stuff like this with fgets. Fgets will return something called null. You don't have to really know what that means. So in our loops, I think I've got an example somewhere that I'll show you later. I'll show you later. I don't want to spoil that example now. Okay. So let's talk about the string library, and then I'll talk about the fgets loops after that. So the three most important functions in the string library are string copy. Oops. I'm going the wrong way. Oh, string copy, string length, and string compare. There's also another two that are quite common, and there's a whole library full of different things you can look through and use. But these are the ones that you'll definitely use all the time. So let's just do an example with those. So over here, I've got an array, and I've made it of length 100. Etc. And in there I've put boots. and it would have the null terminator, and everything after that in the array is just kind of garbage. So that's what I've got in my puppy string. So if I just print that out using %s, it's going to print boots. But what if I decided when I brought home my rescue puppy called Boots that I wanted to call the puppy Finn, and I wanted to change it? So I think I said this the other day. These strings are arrays. We can't just say puppy equals Finn. That's not going to work. If we try and compile it, it's going to complain. It's basically saying, yeah, it's not assignable. You can't just assign one array to another. That doesn't work. What we could do is we could write a lovely loop that moves over one element at a time, and makes sure we've got the null terminator. But we can use string copy because this is really common. And this is how we use it. It's just going to copy all of those characters across. Put a null terminator, and anything after this first null terminator doesn't matter. Doesn't matter that we've got 2 null terminators in a row. This is all considered junk. And now if we print it, it's going to say Finn. Now often we want to know the length of a string, and we'll see an application of that later as well. But again, we could write a loop that goes through and counts through till it gets to the null terminator, but we can use string length to get the length of the string. If I try and get the length of this string, it's going to say 4. So it's the length of the string that we're trying to store. We're trying to store Finn, F-I-N-N. It doesn't include this special character that's helping us program things in the background. It's what a normal person looking at the output of this program would think the size of the string was. Because remember, we don't want to print out the null terminator. All right, so it's just going to say Boots, Finn. Finn has length 4. All right, any questions about these functions before we look at string compare? All right. So string compare basically compares strings. So I don't know why I'm uncommenting these one by one. Let's do this. There we go. Control /. And it does it a bit like, you know, in a dictionary, right? If you've got ant and zebra, you'd start at this first letter and say, well, A is less than Z. So actually, we'd say ant is less than zebra. Does everyone agree? It's certainly not equal to zebra. And as soon as you look at that first character, you know they're not equal. So it does something similar to this. It looks at the ASCII codes and it determines whether our strings are equal. The first one's less than the second one's less than the first one. Well, you know what I mean, I hope. So here, I've got a string that I've hard-coded to say Oscar, and I'm comparing it to Oscar. So obviously we think these are equal. String compare will return 0 if they're equal. So we'd expect this to print out hi Oscar because the two strings are equal. We'd expect this to print out, here it's comparing it to Edgar. It's not equal, it's not going to return 0. We're going to print out you are not Edgar. Hopefully that's sort of clear. We can also check which one's smaller. So would you say Oscar is smaller than Edgar? No. So if we're thinking like dictionary comparisons, Oscar's larger than Edgar. So in this case, it returns a number that's positive. If we were comparing Angela to Edgar, it would return a negative number, right? Because it's less than. So you can do all sorts of things like this. it is much easier to use string compare than write this yourself, even though it's possible. Oh, I haven't saved it. Right, so this is just string compare. It'll come in handy. Now, let's just have a look at this situation here. I've got a new variable and the user's going to type in the name. And then I'm going to compare it to Oscar. And if, you know, Oscar is equal to what I've typed in, it's going to return naught, and I'm going to print yay Oscar. So if I type in Tom, obviously it's not going to say yay Oscar. If I type in Oscar, it's still not saying yay Oscar. What's wrong? Does anyone know? Have I used, oh, we've got hands up, yeah? Yeah. There were two people right behind, like one behind the other one, that both put their hand up exactly the same time. Yeah, I've typed in Oscar, return. fgets has read in Oscar, new line. So I'm comparing basically Oscar, new line to Oscar. Now this is one of the annoying things about fgets, this extra new line character that was pretty good. Oh, so it's teamwork. You deserve a chocolate for the team spirit. I'm glad I didn't have to throw it. That wouldn't go well. Yeah, we've often got this annoying new line character that we may not want when we use fgets, like in this situation, that can confuse us. Now, if we think about, I'm just going to use the word dog because it's smaller. So when I'm using fgets, I could have what we call like a trailing new line character, and I might want to get rid of it. I might not have it, because if the user typed in too many characters and got cut off, it won't have it. But just say I do have it, where's it always going to be? It's trailing, so it's always somewhere at the end. Now, if I do what's the string length of this string, what would I get?
3.
Someone said 3, but actually it's 4, right? So anything that I purposely typed in, like dog, new line, that's all part of the string length. Spaces, anything like that. It's just this null terminator. So my length of this string is 4, and where's my new line going to be if it's there? At what index? Yeah, in this case 3. So this is sort of a way we can always do it. I know that it's going to be at, oh, let's get the string length first. So a user's typing some string in, I don't know what it is. I can find the length of it, and if I go to that length, oh, my one key is sticking, at length -1, I'm going to go to this spot where there might be a new line character. So I can check if there is one there. Now, if there is one and I want to get rid of it, what would be a good way to try and get rid of it? What could I put there instead of it? Yeah? Yeah, I put the null terminator in there. That's the best way to chop off the rest of the string. Now I've just got dog. So that's our magic trick to get rid of the new line. Okay, does that make sense? All right, let's just try if it works. I should now be able to type in Oscar, new line, but it should get rid of that new line to compare it. Oh, but I've got to actually have the if statement after I've chopped off the new line. Yay, Oscar. All right, so you might accidentally do that kind of thing and be confused, but yeah, just keep in mind you're going to have a new line character that might be getting in the way. If I wanted to put this into a function, which would be a good idea because this might come in handy. It's a bit of a long function name. I could do something like this. Remember, this is an array. If I pass an array into a function, it doesn't pass in a copy, so I'm able to actually modify that, like permanently modify it. It's not a copy. So don't need to return it. I could just pass it all in and modify that original copy of the array. So I could put this in here. Now, once you're moving code around like this, often you might have to fine tune a few things, declare this again. And I haven't called this name 2, which was a terrible name anyway. I've called it S, which probably isn't a great name either. It's hard to make up names for programs that aren't really doing anything particularly meaningful. And then when we want to use it, I can just pass my string in. Does it still work? That's always something you should test once you've moved things around. Yay, Oscar. All right, any questions about, yep?
Do you create multiple if statements if you want in case there are full stops and spaces?
Oh, if you wanted to get rid of full stops and spaces, you might have to search through the whole string because you wouldn't know for sure that they'd be at the end. And the same if you wanted to get rid of all new lines and it wasn't just going to be one at the end, you might have to have a whole loop that goes through. And you might then have to shuffle the characters along so there's not holes in there. It's a much more difficult task. I mean, not that difficult, but it's not as easy as this way where we can just chop off that last character. Okay, now just one more thing before we go. This is very important. I've called this string functions danger, so obviously there's something bad about this code. Can anyone see what's wrong with this code? My favorite food's KFC. I've changed my mind. I've decided it's pizza. I'm copying over. Yep.
The KFC array is initialized, so only has the KFC letter, so it's going to be too small for pizza.
Exactly. The KFC, my favorite food array was initialized to say KFC. It's going to look like this. I then try and copy pizza over the top of it, and we get P, I, Z, Z. Uh-oh. We're going over the bounds. And DCC, in this case, because I've hard-coded everything, DCC knows that at compile time. But maybe I read in pizza and I don't know it, and maybe DCC doesn't pick it up, but our program would crash. Oh, I'm running the wrong program. Yeah, it crashes, saying you can't copy pizza into this array, it's too big. Okay, so you've got to be very, very careful with your strings and keeping in mind how big the arrays are that are holding your strings. And also making sure if you're moving characters around that you don't lose your null terminators. They're the trickiest things with strings. All right, now since we love strings so much, let's do arrays of strings. So if one string is stored in an array of strings basically is also basically a 2D array of characters. You can think about it either way. So in this case here, I've got this dimension here, which is basically saying this can store 3 strings. And I've got this dimension saying each string has a maximum size of 5. And that's including the null terminator. So basically, I can store 3 strings with max 4 characters basically in them each. And yeah, sometimes I might want to just think of it like a 1D array of strings. Sometimes I might want to think about it like this, where row 0 is a whole string and the columns are the individual characters. Okay. So, if I wanted to, I can just go to index 1, for example, and that's going to give me a whole row or a whole string. So I could say, go to words at index 1 and print it with %s. That's going to print the whole string cake. Okay. Is everyone happy with that? I could also go to an individual character. I could say, let's go to index 2, which gives me, you know, the whole string. And within that string, index 1, which takes me to the character E. So if I've got an array of strings, the first index gives me the whole string. The second index can give me the character within there. Yep?
What if you tried printing out the null terminator?
If you try, the question was, what if you print the null terminator? If you print the null terminator, often it looks like nothing has been printed. Sometimes you might get a weird looking thing, but often it'll look like nothing's printed and you think, oh, well, it doesn't matter. But sometimes when you're doing things like auto tests, the auto test doesn't see visually like we do. The auto test will know that that character's there and it'll say, no, this is different. And people can be looking, thinking, well, I've printed dog. All I can see is dog, and that's dog. What's wrong? You might have that invisible null terminator. So those weird things can come up. Yeah, it just depends. That's the trickiest case that really gets students very confused. All right, so let's, oh yeah, question?
What if you just want to print out the column itself rather than just the row?
Oh, if you wanted to print the column, then you just have to basically do your own kind of loop that went through it, yeah. Okay, so let's just have a look. We're not going to do too much with these arrays of strings yet, but they're crucial to understand command line arguments. So here I've got basically the same scenario, but I've made it so I could possibly store 20 strings and that they could be longer. They've got a max length of 10, so I could have 9 letter strings plus the null terminator. But I've still just got hat, cake, and tea. Now I'm also keeping track of the number of strings I've got, which I'll explain a bit more later. People often find that confusing. But again, I can print one string like this. What's this going to print? Line 27. Unused variable, I'll use it later. So I can think of it, I can just even look at this, or I can look at this sort of picture that I drew. But we're basically going to row 2 or just string 2, index 2, and that would print out the whole word T, which is confusing, isn't it? TEA, the word T, not the letter T. Whereas if I do this, what character am I printing? Yeah, I'm going to the cake string, because that's the one at index 1, but I'm going to the letter at index 2. So the C is at index 0, 1, 2, and I should be getting cake. So it should print out the word T and then the K. Okay, is everyone happy with that? So the first index gives you the string, the second index gives you a particular letter within that string. Okay. So what if I wanted to print out this whole array? It's actually a lot easier than what it might seem to be, because I can just treat it like an array of integers and do my printf with %s. I can just go to index 0, printf %s and print hat. Go to index 1, printf %s, print cake. So down here, I've just got one of these types of loops. And I think what people get very confused about with strings, for each individual string, it's got a null terminator. So I don't need to know the size of each individual string. But if I've got an array of strings, I need to know how many strings are in that array. So I know, because I could have 20. So I'm keeping count that I've got 3 strings. So I've got that size, but I don't need the size of the individual strings. Hopefully that makes sense. And down here, I use that size in my loop. So how many strings are in the array? Sometimes you see people in this scenario put this in, but that's for an individual string when you're going character by character. Okay, so this is just like now printing out an array of ints, if we're thinking of it at the string level and we're using %s. Let's try it. Yay, it's printing out hat, cake, and tea. All right, now what if I want to add more stuff to this 2D array? I want to add sun. I want to put sun so it's here. Is this going to work? No? If not, what do we have to do instead? Yep. Oh, well, num strings, I could increment that after. Oh, yeah, I've got the wrong index. Oh, no, that's all right. We've got enough for 20 strings, so we can put this in here at index 3, and we can increment this so now we know there's 4, so we can print it out. What's wrong with this, though? Yep.
Do you need an fget?
Well, we could do fgets actually and read it in rather than me hard coding it. But if I'm hard coding it, that's okay. Yep.
String copy.
Yeah, we can't say equals with strings. We're trying to assign a string, a whole string at once. We either need a loop or we can use string copy. So you'll do that again and again because you're just going to want to make something equal to something, right? Oh, but you've got to spell string copy correctly. Did I do it? I've added sun. Oh, now I've got to print it out. And I've updated this so now it knows, well, there's 4 strings. Not 3 anymore. It's going to print them all out. So this is just a little bit of an intro to arrays of strings. Once you know strings and you already know arrays, there's nothing really new, but it just adds to that sort of, I guess, confusion and complexity. All right. Any questions before we move on? All right, we've got a little bit of time to talk about command line arguments. How's everyone's brains going? We've got one thumbs up. No, 2 thumbs up. Everybody else is looking like this. Okay, let's just talk about what command line arguments are. The average person walking around the world does not know what a command line argument is. And I'd assume most of you don't know it unless you've already formally learnt some kind of programming before. But basically, so far when we're using our programs, we run our program first, and then we might say, enter your name, enter your age, and the user types something in, and we read it in with fgets or scanf, right? That's how we've been doing input to our program. After you've started running it, interacting with it. And we've always used this as our main. Oops. We've always used this version of our main function. And our input's always been void, which means we don't have any input coming into our main function. That's the way we've always done everything. Well, command line arguments allow us to give inputs to our program basically before they've started running, and that gets fed into the main function. So when we're using a program like DCC, we don't just type in DCC and then DCC says, please enter the name of the program you want to compile, and we don't sit there then typing it in. Please enter the name of the executable, you know. We do it all like this on the command line. And yeah, this is what we call command line arguments. It's everything that the user's typed in on the command line, and that can get fed into the program before it's even running. And it comes in via the main function. We have to change it, I'll show you on the next slide. So we can do that too. We can have our program running, and before it's even running, a user can enter these command line arguments straight in. And often we can use these to have certain options or control our program in some kind of way. And this can be a handy way of doing things. So that's what command line arguments are. Does that make sense before we try and work out how to do them in C? Often people struggle to understand what they even are, or why on earth we need them. Now, once we use command line arguments, we've got to use this kind of main. This is the prototype we'll use. And you're probably going to forget that and won't have it memorized at the start, don't worry. But this is like a function prototype. Now, this first input to the main is of type int. We all are comfortable with ints. And this is just, well, how many command line arguments do I even have? It's basically like, yeah, the size of the command line arguments. This thing over here, which has a star and looks terrifying, this is basically an array of strings. It's got a slightly different syntax we'll learn about later, but this is an array of strings. So if we use this as our main, instead of having main void, we can use command line arguments in our program. Now, when we run our program, that allows the user to type stuff in, and it's going to be passed in. Now, in this case, our args variable, which the main gets, it's in the inputs to main, it's going to be 4, because the user's typed in 1, 2, 3, 4 command line arguments. Now, in Linux, it divides up the command line arguments with white space. So if you've got white space in your command line argument, you've got to put it in quotes. So this is treated as one command line argument. And the strings aren't actually part of it. I hope that makes sense. So that would be hello space world that would be fed in. So yeah, argc would say, well, 4, and argv would be an array of strings that has these strings in them. And it might seem weird because we've actually got this one here at the start, the thing we typed in to run the program. So you can't forget about that. That's included. That will be in there. And then all the rest of them. So you can do things like check how many command line arguments do I have, go and look and do string compare and see what ones you've been given, etc. So in this, and we'll see better uses of them later, but for now, can we just print them all out? So first of all, I can just print out how many command line arguments I actually got. I know that we're always going to have an argument at index 0. argv index 0 is always going to have whatever the user typed in to run the program, and I can print that. And then I've got an array of strings. I can just use a loop like we just saw before that goes through the array of strings and prints out every single item in there with %s, starting at the first index, going up to the size of the array, which is the information we get in argc. All right, so this stuff is typically pretty difficult when people first see it, difficult to understand. Let me just try and run this and then we'll have a break. Okay. But yeah, just a reminder, none of this is going to work if we still had int main void. We wouldn't have access to argc or argv. So this is the first step, putting that correct main in. Then when I run my program, if I just run it like this, what do you think argc is going to be? Yeah, 1. It's always going to be at least 1. And we're going to have one string, and it's just going to say we've got one argument. It's /command line args. The argument at index 0 is /command line args. All right, if I do something like this, we're going to have how many command line arguments? Yeah, 1, 2, 3, 4. If we loop through and print them all out, we can see at index 0 we had this one, etc. It just goes through and prints them all out. Does that make sense? Yep.
So it counts it for us via the spaces, and if we want to include something with a space, we put a quotation mark.
Yeah, that's right. Yeah, and that's the Linux kind of side, is splitting things up based on space. So yeah, I could say, what a stupid thing to say. Something like that, and that would be considered one command line argument. Okay. All right. Let's just have a look at this example. Now imagine I wanted to do something where I could run my program and type in numbers, and it could just go through the command line arguments and add them all up. It wouldn't include like the name of the program, but it'd go through the rest of them and go, well, 9 plus minus 87 plus 23, and spit out an answer. What would be wrong with this code? So let's have a look. I've typed in bad sum. That would be at index 1. I mean at index 0. So in my loop, I'm starting at index 1 because I don't want to try and include this as one of my numbers. Then I've got basically 9 minus 87, 23, whatever. And I'm going through, I've got a sum, and I'm going through every command line argument, and I'm saying, okay, let's add the 9, the minus 87, whatever that is, 23, 8,376. What's wrong with this code? Yeah? Yeah, these are all strings. So this is not going to work. That's correct. Chocolate admins, I think a few other people got ripped off. If you got ripped off and answered questions, come up in the break and sorry, they're so busy on the chat. So yeah, these are strings. So let me just show you what the compiler will say. It's saying, warning, conversion to int from char star. So basically what you're doing is you're trying to take some sort of number, which is an int, and add it to like a string. So if I've got the number minus 87, it's basically an array. You can't add an array to an integer. It doesn't work. We look at it and it looks like a number, but it's actually a bunch of characters. They all have ASCII codes, but it's not one even number, right? There's a bunch of ASCII codes in an array and a null terminator. We can't do it. What we could do is we could write some kind of loop to go through and convert this into a number. Actually, it's not that easy to do. We could do it, but there's a function that can do it. I recommend people try and do it though. Maybe it's a lab question. But there's a function called atoi that does exactly this job that we want right now. Atoi will take a string number and convert it into an integer number. And the I means integer. Now, if you put hello in this, or something that's not an integer, it'll just give you naught, I believe. So it won't crash, it'll just give you kind of weird nonsense. So just quickly before the break. So this is a prime example of when you're getting things as strings, even if they look like numbers. So now it compiles, and now it can add those up. I think that's right. And all we did was we put atoi, like we put our argument inside this atoi function. It converts that string into an actual int that we can do maths on. So just, yeah, if you've got string numbers that look like numbers, but they're in strings, you can't do maths on them. All right, let's have a break. We'll come back at about 5 past, and we're going to do a sort of a revision, putting everything together, not including string stuff really, everything else, that hopefully helps with the assignment. Okay, let's get back from the break. Let's get started again. So this part we're going to do a program. It's a game. It's very loosely called a game. It's called Mud and Bones. Basically, we've got a dog moving around on a map, and the map contains locations that have either grass or mud, and they might also have a bone. But basically, the dog's trying to move around the map and collect bones. Oops. But if he steps in mud, that's not a good thing. It spreads it, and he's only allowed to step in mud 3 times. Now, the rules of this, I just made them up. It's not that important. They might not all make 100% sense. But basically, the game ends when the dog finds all the bones, or if the dog steps in mud 3 times, so he has to go home for a bath, or if the player presses Control D. So that's basically what we're doing. Now, we've been given some starter code, and we've got some hash defines already. Basically, the size of the grid, it's 8 by 8, 8 rows, 8 columns. Every cell in the grid is of type struct location. And our struct location has an item type and a ground type. So the item type, every location will either have an empty item, like no item or a bone. Every location will have a ground type of either grass or mud. Okay, so we've got struct with enums in it. And we've been given a map, and that map is sort of an 8 by 8 array of these struct locations. So we'll have rows 0 to 7, columns 0 to 7. Okay. And then if we look in a bit closer, every location on this map, like these are all struct locations, so they all have an item and a ground type. So the item might be empty or bone, the ground type might be mud or grass. So every cell is a struct with values for these 2 fields. Is everyone sort of happy with that? So if we were trying to work with this, well, we're in a 2D array. So we first of all have to give basically the coordinates or the indexes for a particular struct. So if we went to our map, that's the name of our array in this case. If we went to the map at index 0, 1, it'd give us this whole struct. I'd then have to do dot, say dot item to get this value of bone out, or dot ground to get this value of mud out. Okay, does that all make sense of how we access these 2D arrays with structs inside? Okay, good. Then we've been given some functions that are already written for us. We've got something to initialize the map. So it basically takes this map in and sets a whole bunch of things to have empty or grass or mud or bone. That's already done for us. And then we've got a function that can print the map. So to use print the map, we've got to pass in the map and also all this other information about, where's the dog located? What row and column is the dog on? How many bones has the dog already found? How many times has the dog already stepped in mud, etc. And that'll print out the map for us. So we've got some starter code already. It's got, some constants, the enums, some prototypes. And basically, oh, and the starter functions are down there. You don't necessarily have to read or understand them. But if we compile what we've already got and run it, doesn't look very nice, by the way. I'll make this a bit longer. It prints out basically the map. Every single cell sort of has 2 characters that get printed out. So dot means grass, M means mud, nothing means nothing for the item, whereas B means bone, right? So everything's either got dots and blanks or 2 kind of capital letters. So it's 1, 2, 3, 4, 5, 6, 7, 8 rows and 8 columns. Then it also prints out the number of bones found and the number of times the dog stepped in mud so far. So there's a few things that we need to do. I don't know how much time we'll have to do all of this, but the first step is we need to get the starting position for the dog. So we've got to scan in some coordinates from the user and set the dog's starting position. Now, I decided that if the user types in something illegal, we just go stick the dog at position 0, 0. Okay, so that's what we've got to try and do. So let's just start with that. Now, often in an assignment, you want to read through the whole sort of spec to get an idea of what else might be coming up soon. But also you don't want to get too overwhelmed with what's coming up soon either. So for today, I'm just going to get started. So we need to read in the dog's location. Now to start with, I'm just going to make 2 variables, dog row and dog column. And I'm just going to read them in with scanf. And for now, I'm not even going to check if they're correct. I just want to see if this is working and if I know what's going on. So I'm going to read these in, and then I'm going to try and print the map and see if my dog appears. So I'm going to print the map. I'm passing in the map. Now, if I looked up the prototype, this is meant to be the dog row. And now I've got hopefully a valid dog row and a dog column. These are the bone count and the mud count. I can leave them at 0. Let's compile it and let's run it. So it says enter the dog's location, and I'm going to say 5, 0, and I can see that the dog's here, 0, 1, 2, 3, 4, 5, 0. So I've been able to place the dog, but if I type something like hello, my program's going to crash. If I type something like -1 or -2, 99, my dog is somewhere off the screen wandering around. It didn't crash things because I haven't done enough code to use those indexes properly. But yeah, it's not what we want. So we've got to check for these situations. Yeah, how can we do that? So first of all, how can we check if the user didn't even type in 2 integers? Yeah, what should scanf return us if we type in at least legal integers? 2. We've got 2 integers we're trying to read in. So if this is not equal to 2, we know they didn't even type in proper integers. So we would want to make sure we just set the dog row and the dog col to 0. And we want to make sure we do this because maybe they typed in a dog row and then typed hello. So we want to make sure we set them both to 0. But, you know, the user could have typed, like I did before, -1 and 99, which is outside the bounds. So we also want to check whether it's valid. Now we can stick code in here to start checking if it's valid, but we're probably going to have to do something like this again, maybe check if these are valid. So maybe we want to write some kind of function. So let's assume that we've already written it. Imagine I've written a function, let's at least write the prototype, that checks it can take in a row and column, and it can just check if it's valid. Let's imagine we've already done that, and it will return 1 if it's valid, and it returns 0 if it's not valid. We could then use that function and say, well, if I call my isValidPosition function, and I pass in this dog row and this dog col, if it returns 0, I know that it wasn't valid. All right, so and this is kind of called a top-down approach, where I'm thinking it would be really handy to have this function. Let's write the prototype and let's think of how I'm going to use it in this context. Then I can actually go and write it, because I'm fairly confident I'd be able to write that function pretty easily. Yep.
Just out of curiosity, how would you know what print map, what you're supposed to put into print?
Now usually you'd look at, something's happening over here. You'd look at the prototype, or in this case, like if it was a proper assignment, there'd be details about how to use it. So there was an example here, and if you do look at the prototype, it says you pass in the map, then the dog row and the dog col. So often by the prototype and or the comments above the function and or like the spec if it's a proper assignment, yep.
And with like the structs, would there be like a situation where you would just pass in the rows and the columns, or would you always just pass in the whole struct, the whole thing?
So the question was, would we sometimes just pass in the rows and columns of the map? I think typically you're just going to pass the whole map around. Look, you could just pass in one row of it. Yeah, it would be up to you. But for this print map, yeah, you're going to pass in the whole map, yeah. All right. But yeah, when you can't just completely pretend forever that you're going to write the function. At some point, we do have to write the function. So let's try and write this function to see if a given row and column okay. So there's different ways we could approach this. I could assume it's valid, and then I can check a condition to see if it's not valid, and then set it to not valid. But how can we tell if this row col is not valid? What are we checking for? What's one thing that would make it not be valid? So this is a position that we're going to use to put the dog on the map. For example, -1 is not valid for a row. Why is that? Yeah, it's less than 0. So we just check. If row is less than 0, that's not valid. What else is not valid? Yeah, if col is less than 0, that's not valid. What else is not valid? Yeah, so if row is even bigger than or equal to 8, and actually there's a hash define, or what else? Yeah, if col is greater than or equal to map columns. If any of those are true, well then this is not valid. This is not a legal position, and would say valid is false. So here we're using our int that we're returning for like a true false thing. And you could write this differently. You could have checked if it was valid, you know, you could have done your if statements differently. But basically you're checking for the row and the column whether they're within the bounds. Okay. And then up here, we're using that so we know straight away, do we just need to set the dog row and dog col to 0? Let's just check it. So let's just check if it can go to a valid location still. Yep, I've got the dog at 77. Now if I do -2, 99, it should just go put the dog at position 0, 0.
This has to be or, not and.
Oh, did I do and?
No, in the if statement.
Oh yeah, it should be or. Yeah, thank you. So yeah, either one of those, then it's not valid. Okay, here we go. Let's try again. So let's do 7, 7. Thank you. Who said that? Thank you. You just definitely deserve some chocolates. So I've got the dog down in the bottom right corner, which is where I put him. If I do -2, 99, it should give him in position 0, 0. All right, is everyone happy with that, kind of? All right. Now, the other thing is, if we think about it, if I put the dog at position 0, 1, which is here, I'm placing him straight on top of a bone and mud. Now, depending on what the spec says, I don't know, you might have to do other things, but I've decided, yeah, if you put the dog on a bone and mud, when you're placing him, that counts as a bone and a mud, right? So now I have to make sure I'm updating it that the dog has found a bone and the dog has stepped in mud. So now I'm going to have some way of storing that. So I'll start with a bone count of 0 and a mud count of 0. Then if I work out that the dog row and column that I'm placing it on has a bone, I can increment it. If the dog row and col has mud there, I can increment that counter as well. What does everyone think about how I'm storing all of these variables? Do we like having them all as separate integers? Yeah, it might be easier, especially once we start having more functions, it might be easier to package this all up in a struct and then be able to pass a whole struct into different functions. So I could make a struct, I could call it, I don't know, what would we call this struct that we're putting this data in? I could call it like game, or I could call it dog data, or I don't know. It just really depends on what else you're going to put in it. But let's do it now. The earlier you make these decisions, the better. And you might decide to do things differently, right? Everyone's going to make different choices. But I'm going to call it dog data. About the dog and where he is and what he's already done so far. And because it's inside my struct called dog data, I'm just going to call it row now and col. And as I go through and implement more, I might realize there's more data I need to store that I might put in here. Okay? I mean, you could also have a game struct that has the dog data in it and the map in it. It just depends how complicated things get. This scenario is pretty simple, so I might just leave it. So now, instead of having all these separate variables, I'm just going to say struct dog data, and I'm just going to call it dog. This is my variable called dog. It's going to contain all that information. I can still go and set the bone count field to be 0 and the mud count field to be 0. So I've got my dog, the bone count set to be 0, the mud count set to be 0. The row and column at this point in time haven't been set, but I'm going to set it in here. So now I'm going to have to go and change all this, which is what happens once you decide to restructure your code. You've got to go change stuff. So instead of it being dog underscore col and row, it's going to be dog dot. Oh, I missed some. Right, that's all in my dog thing. Oh, and when I'm printing the map out, I should be passing in my dog bone count. And my dog mud count, I think, yeah. So now that we've changed that, before we go any further, we should probably compile it, because it's easy to introduce errors when you start. What we did was, I guess, restructuring our code. Okay, all right. I didn't test it thoroughly, but it seems to sort of work. Now, what we want to do now is basically update all of our data based on where we're putting the dog. So basically, I want to say, well, if the dog is in a position where there is a bone, increment the bone count. How do I do that? How do I work out if the row and the column where the dog's standing has a bone on it on the map? Yeah?
The dog row and column have to equal the position of the bone in the mud. So we could find something that when the dog row and the dog column equals the position, prints out or increases the bone.
Yes, so we've got to use the dog row and the dog col as the position in the map. So if I take my map, what row and column am I interested in? I want to have a look at where the dog is actually standing right now. I want to go to that particular row and column in the map and look up what's in there already. Now, I think it's called item. If the item equals bone, then the dog has found a bone, and we increment the dog count. If the dog if we check the ground type and it's equal to mud, then the dog has stepped in mud. So the mud count is increased. Does that look okay? The other thing we need to do is once the dog finds the bone, that bone is no longer on the map. Right? The bone should disappear because the dog's eaten it, supposedly. So how would we do that? So the map in that position, instead of being a bone, should now be empty. That gets rid of the bone. So the dog basically eats the bone and then we go to the map at that position, and we say, well, no, there's no bone now, it's empty. Okay, something like that. Now, when we step in the mud doesn't magically disappear. The mud stays there, but if we're the dog, we find the bone's gone. Okay, so we need to do something like this. So let's just try this. And obviously, if I go to 0, 0, there's no mud, there's no bone. If I go to 0, 1, there should be a bone and mud. So our counters here, when we print the board, it should say we found 1 bone and we've stepped in mud once. And it does, so it's updated this, right? I can't tell if the bone's been taken off the map because the dog's being, is being printed. But we were able to tell that the dog was placed in mud and on a bone and update the mud and bone counter. Any questions? Now, who thinks this might be useful? Because later on, the dog's going to be wandering through this map, and we're going to be doing this again and again. We don't want to copy and paste this all the time. We want to move this into a function. We can call the function, what could we call the function? We could call it, it doesn't really matter. Anyone have a suggestion? Yeah, map update. Perfect. And for now, I'm going to make it void, which actually is wrong, but let's just try it. Map update. What input does it need? It needs to do all of this sort of stuff. Oops, I just deleted it all. It needs to do all this kind of stuff. So what's it going to need? It definitely needs the dog. We want to pass in the dog struct, and we want to pass in the map. So we've got to pass in the map and then the struct dog. And actually, it's going to get quite wide. So it's going to look like something like this. Then we've got to go and actually implement this. And I'm going to pass in, I'm going to move this code basically. And I've called it everything dog and map, so I don't even have to change the variable names, I don't think. Then in here, I can just say, well, what did we call it? Map update. Map update. I pass in the whole map. I pass in the dog. And that goes, and hopefully, if it works, it'll go and do all those updates. And I'll be able to use that function again later. And honestly, this should probably go in a function too. We could call it like initialize dog or something like that. I'll leave that for now. Who thinks this is going to work? I've kind of said it's not going to work already. So I'm going to enter the position 0, 1, where we know it's going to find a bone and mud. And we know that individual code, the logic of that code did work before. But now I've moved it into my function. It's not updating the bone and the mud. And this is a real stumbling block when people start using functions and they say it worked when I wrote it, but I tried to move it into functions and everything broke and I don't know why and I hate functions and my main's going to be this long kind of thing. What's wrong with what we've done? Yeah? That's basically the right idea. And why, the thing was we've got to return these updates, but why? Yeah? It's a void, that's right, but why should a void not work in this situation? Yeah?
Easier expand the structs of the dog itself, because you need the data to update.
Yeah, so remember, if I pass in a struct to a function, let me just draw this. I've got my dog up here and it's got row 0 and 1 or whatever, and the counts are 0 for the bone count and the mud count. I call my update function. When I pass in a struct, a lone struct, it gets passed in by copy. So in that function, we're going, well, if the dog's here and the dog's there, let's update my bone count. If the dog's in mud, let's update my mud count. And it's doing everything properly. It's all the logic's fantastic, but this is a copy. This is the copy of the dog data, and that's what it's updating. So when the function finishes, the original dog data just still has the original data in it. So when we're passing a struct into a function, it's not going to change it. It's going to change it locally, but it's not going to change the original copy. So the solution is that this function has to just return the dog again. Here's my updated dog. Let's return that. And, you know, copy it right back over my original dog data. Yep.
But isn't it an array? Isn't an array like global?
So here we've got two things we're passing in. We're passing in the map, and the map is an array. So when we pass an array in, we're getting access, even if it's an array of structs. If it's an array of anything, we have access to the data. It's not a copy. So that's good news for us, because when we're updating the map and removing the bone, that's going to work. But when we're passing in one individual struct, it's a copy. It's a copy. So to solve this, the map's fine. It's an array. We can update it to our heart's content. The dog, we can update it, but we're updating the copy. So the solution in this case would, be to return the dog. So we'd have to have a return type of struct dog data. And this is the thing that I think really is difficult when people are trying to make their functions, and restructure their code. So if we do it like this, dog equals map update, and down here, we return this updated dog, it's going to work. Oh, except now I haven't changed this prototype. It's also got to say we're returning the dog. So now let's try it. I'll put it at 0.1. And it's updating the mud and the bone counter. Again, we can't see the map under the dog, whether their bone's still there or not, whether we remove the bone effectively. We'll see that later. Does that make sense? This is a really important thing that in the assignment, if you're trying to break things up into functions, you might face this scenario where you think you've updated a struct. I mean, it depends. Everyone will do their assignment differently, but this kind of thing can come up. Yep.
Would there be an issue of defining the function as a struct, but then passing an array through it? Would there be an issue with that?
If you define it as one struct, you've just got to pass one struct. You can't pass an array in interchangeably. So here, we're passing one array and one struct. So yeah, you do have to match it. If you didn't want that, you'd have to.
But arrays can fit into anything as long as you have something else that matches, right?
If we have a function with this prototype, you're going to have to pass in an array of exactly this dimension of exactly that type. Yes, yes, yep. An array of structs in this case, or this would have to be a dog data struct. All right. We've placed the dog, we've done error checking, we've updated things. We actually want to go and let the user direct the dog, and we're running out of time, direct the dog around the map, okay? I'm going to call this find bones, and again, I'm going to pass in my map and my dog. For now, I'll leave it void, but as you go, you might realize, okay, maybe I do need to return something in here if you're planning ahead, which right now we're not really doing. So I'm going to write find bones, and this is going to be the thing that just keeps looping around. So to start with, and we're going to do the whole WASD thing. If the user types in W, the dog's going to go up. If it types in A, it's going to go left, etc. And we're not going to worry about winning and losing yet. We're just going to keep going until the user types Control D. So this is just a standard loop, reading in a character until someone presses Control D. So how do we do that? Everybody? So I'm going to have some char to move things that I'm storing things in. I'm going to call it move because they're entering like a move, a game move. And if I'm reading in a char, what am I going to use? Scanf. I'm going to use %c. Is this the best version of %c to use if I want to skip spaces and new lines? Yeah, I might want a space here. It depends on what we're doing. But if we're just looking for a W, an A or a D or an S, and spaces and new lines don't count, we want to do this. And I want to keep scanning while what? This returns what? 1. Excellent. So this is my loop. And what are my conditions in here going to be? What am I checking for? And let's just say, for time's sake, we're not going to check if it's legal. Let's assume they're really typing in WASD. And let's assume that they're not going to try and make the dog go off the grid. But these are all things that you should check. But to make it simple to start with. So what are we checking for? Yeah, if it move equals W, we do one thing. Else, if move, if I could type, equals A, do another thing, etc. Do we think it's good to type it in like this, WASD? Tutors? No, we should use what? Yeah, we should probably use hash defines. So what we should probably do is go up the top and say hash define, something like input up. Is that okay? Would you think that's an okay name? Yeah. Okay, move up. And we're going to make it W, etc. So we want to do that. Move up, move left. I like to go up, down, left, right, but anyway. W, A, S, D. Right? Do something like that. Then down in here, oh goodness, where is it? We say move up. And actually, I think up, down together, like that, and then We could do errors checking, but we're not going to do it. Now, if I'm moving up, imagine the dog is here, and I say, you know, move up to here. What's changing in the dog's position? The row. And how is it changing? Subtraction. So the row of the dog, we're subtracting 1 from it. That will move the dog up. I've got 2 ups. The dog row, if we're moving down, is going to increase. If I move the dog to the left, col minus minus. If I move the dog to the right, col plus plus. Now, I'm updating the dog. Hang on. Where's my function name? What am I doing? I didn't copy it properly. And I'm doing that again and again, but each time I do that, what do I have to do? I've got to print the map, and I'm going to steal that line of code from here. Should be the same. But what else do I have to do?
Need to return the dog as struct.
Well, I've already got the dog passed in. I've got the dog passed in, so...
To return it, changing the row as validity.
Well, it just depends. That's true. If it depends what I'm doing with this function. But actually, what do I want to do before I print the map, though? Yeah?
You want to change the previous tile it was on back to empty.
Yeah, I want to do all of this stuff that I did in my map update function. I need to call this function so it goes and updates whether I found bones, moves the bones off the map, all of that stuff. I need to call map update. So I move the dog, I change the position, I pass it into move update, that checks whether I'm now getting a bone, I'm stepping in mud, it updates everything, then I print it. Oh, it's called map update. And I pass in the map and the dog. Let's try this and then we'll have to finish. I'll get rid of my scribble. But I'll put the dog at 0, 0. And hopefully I can move around. Now I should find a bone and step in mud. Uh-oh, it didn't work. Why didn't it work? I didn't, does it, yeah?
You didn't put struct.
I didn't, I've called map update. I've passed in my copy of my struct again. It's returning something, but I've ignored it. I've got to say dog equals map update. So I get the updated changes. So let's start again. I didn't even do that one on purpose. I just forgot. Let's move the dog to the right. Yes, it found bones and mud. And we haven't, and if we go down, it's finding the bones, it's taking the bones off the map. There's no winning because we haven't programmed that in yet. Now imagine, I've tried to, I don't know what I typed in, but I've tried to walk off the map. I've tried to go down again, and I haven't done any bounds checking. So what you would need to do is, before you change this dog's row to row minus minus, you might just want to check if that's valid, right? If I'm on row 7, I can't go to row 8. Or if I'm on row 0, I can't go to -1, or however you do it. you'd have to check that and do whatever they told you to do in the assignment spec, whether that's ignore it. I think in the snake thing, the game's over if they go over the bounds. Whatever it is, you've got to kind of check for that and do it. You don't want it to crash. So the things we didn't have time to do is what I called stage 3. The mud spreading, we didn't have time to do. Winning the game, we didn't have time to do. We'll see if we get time tomorrow. We may or may not. Hopefully that helped if you haven't got started. All right, thanks everyone. I'll see you online tomorrow.